You won't always be differentiating functions in the form of y equals f of x. Functions in the form of y equals f of x are called explicit functions. There will be times when you will have to differentiate implicit functions. An equation like x squared plus y squared equals 4 can involve y as an implicit function of x. When we differentiate implicit functions, we have to differentiate with respect to x. So write this down as your example. To differentiate x squared plus y squared equals 4, you have to differentiate each term with respect to x. The derivative of x squared with respect to x is 2x. But when we take the derivative of y squared with respect to x, we have a problem. The variable y does not match up with the variable x. But with the help of the chain rule, we can go ahead and differentiate y like we normally would. We just have to multiply it with dy dx. And I'll explain more later how the chain rule plays a factor in this. But just know right now that when you differentiate a variable y with respect to x, you have to multiply by this dy dx. Okay, so now we're setting it equal to this derivative of 4 with respect to x. Well, 4 is a constant, so that'll just be 0. So we have 2x plus 2y times dy dx equals 0. So let's solve for dy dx. Using basic algebra, we can subtract 2x. So we have 2y times dy over dx is equal to negative 2x. And we can divide by 2y to get dy over dx is equal to negative x over y. And that's the derivative. Okay, let's look at another example. Find the slope of the tangent line to the graph of y cubed minus xy equals negative 6 at the point 7, 2. So we're looking for a slope. And it's the slope of the tangent line to the graph of y cubed minus xy equals negative 6. So we're going to have to take the derivative and we're going to have to differentiate implicitly. So when we take the derivative of y cubed with respect to x, we have this problem of taking the derivative of a variable y with respect to x. So you would differentiate y cubed like you normally would, so 3y squared, but you have to multiply with dy dx. So we're going to take the derivative of each term individually, and we start off with the derivative of y cubed with respect to x. So we have this problem of taking the derivative of a variable y with respect to x. So we differentiate like we normally would. Y cubed is 3y squared, but we have to multiply with dy dx. Now we're going to subtract the derivative of xy with respect to x, but this is a product. So it's the derivative of x with respect to x times y plus x times the derivative of y with respect to x. And then we're going to take it, or we're going to set it equal to the derivative of negative 6 with respect to x. Well, that's a constant, so it's going to be set equal to 0. Okay, so we have 3y squared times dy dx, and we're subtracting the derivative of x with respect to x times y. Well, the derivative of x with respect to x is just 1, plus x times the derivative of y with respect to x, and the derivative of y with respect to x is just 1 times dy dx. The reason is because you would normally differentiate y just like you normally would. The derivative of y is 1. The only thing is we have a problem. A variable y with respect to x, we have to multiply by this dy dx. Okay, so we're going to set all of this equal to 0. And what we want to do here is we want to solve for dy over dx. And if we clean this up a little, we will have this. And we can distribute that negative. We can distribute it into the y plus x times dy dx. So we have 3y squared times dy dx minus y minus x times dy dx equals 0. Now, what I'm going to do is I'm going to group all the terms that have a dy dx. So this can be written as 3y squared times dy dx minus x times dy dx minus y equals 0. And I can factor out a dy dx so that I can solve for dy dx. So now I can add y to both sides. And I can divide both sides by 3y squared minus x to get the final derivative of dy over dx is equal to y over 3y squared minus x. Now, we want the slope of the tangent line at the point 7, 2. So let's plug in the point 7, 2. And this is the notation you would normally use when you want the derivative at a certain point. The derivative of y with respect to x at the point 7, 2. Well, we know that the point 7, 2 means x equals 7, y equals 2. So we're going to plug that in to get 2 over 3 times 2 squared minus 7. We do the math and we get 2 over 5. That'll be the answer, and that'll conclude the video.